Good day, everybody. Welcome to Corona Maths. In front of us is not, luckily for you, your teacher, but it is the video recorder and the director of this fine production, Brogan McEwen. Say hello, Brogan.
Good day all, good day all.
Right, I shall now be taking over and he shall be behind the lens. Move this way, please, Brogan. Right. Okay, so Brogan, you're going to have to occasionally get some close-ups so they can see what's going on.
Okay.
So, girls, this comes from your notes on combinations. We're on page 5 of the notes. Okay. And the heading in your notes is allocating people, but we don't want to be biased. It could be anything. It could be dogs. It could be hippos. Okay. 2 different groups. Right. Just, you'll be pleased to see how corona-friendly we are. Dettol. Okay. Vacuum cleaners. The corona toilet paper. Okay. We are fully emerged in this corona thingy-mabob. Right, so example 1. If you have different size groups. So in your notes, you'll see this example. Okay, I would suggest you listen to the video, okay, and then go back and try fill things in yourself. It's up to you, though, how you want to do it. So, in that example, it says we've got 4 people. They've been given the unique names A, B, C, and D. Okay, and you've got to allocate. We want to find the number of ways that you can allocate, divide the people up so that there's one group of 3 people and one group of 1 person. So, the first thing we could do, we could have people in, we could have A, B, and C in that group, and then person D will be in that group. So we've got one answer so far. Then we could have what? A, B, and D, and have C over there. And then we could have B over here, which leaves us with what? B, not B, A, C, and D. And then we could have A over here, which leaves us with B, C, and D. So those are all your choices. A group of 3 and a group of 1 from the original 4. Okay. So how many ways we have in total? Well, just by inspection, you can see that there are 4 ways that I can arrange 4 people into groups of 3 and a group of 1. Okay. So obviously if groups get bigger, that gets a little bit complicated. So in terms of combination languages, I shall now demonstrate the squat technique. In terms of combinations, okay, what are we doing? We are selecting, first of all, 3 from 4, and this is your group of 3 from 4. Then what do we have to do? We have to select 1 from the remaining 1. Okay, so there's 3 from 4 and then 1 from 1. Okay, and if you go work that out on your calculator, you're going to get an answer of 4. Okay. Right, hope that all makes sense. So there's no problems there. Okay, you can see the different groups. What becomes interesting, Brogan McEwen, is when you have the same size groups. Okay, so again, we're going to start with 4 people, person A, B, C, and D. In this class, you're not just a number, but sometimes you are just a letter. And you allocate it into 2 groups of 2. So, what are our choices? So we could have A and B in this group, which means that C and D will be in the other group. Okay. Then you could have A and C in this group, which leaves us with B and D in that group. And then we could have A and D in this group, which leaves us with B and C in that group. So we've done everything with A. Then we could start with B, and we can have B and C in that group, in the first group, which leaves us with A and D in that group. And then we could have B and D in this group, which leaves us with A and C in that group. And lastly, we have C and D in this group, which leaves us with A and B in that group. How much fun are you having, Brogan?
A lot.
A lot of fun. So you'd say, okay, well, that's great. We've got 1, 2, 3, 4, 5, 6 solutions, so the answer must be 6. But is it straight fact 6? No, it is not. You've been fooled. Why? Because if we look here, here you've got person A and B in one group and C and D in another group. And that group appears again over here. A and B, C and D. Then we've got person A and C in one group and B and D in another group, but that group occurs over here. Okay. And then we've got A and D in one group and B and C, but that's the same pairing up over here. So in fact, the answer is not 6. Okay, because there's a problem of overcounting when I have groups which are the same size. So if you're selecting groups of the same size, something and something of the same size, or doesn't matter, but and matters, then you're going to get a problem of overcounting. Okay, and the way we overcome that counting, so first of all, what is the actual answer to this question? How many arrangements are there? Well, there are actually only 3. Okay, so the solution, how many ways you can allocate 4 people into 2 groups of 2, that's going to be your solution. Okay. Generally though, you don't have to go through this whole process. You just got to remember this. There's a problem when groups are the same size. Okay. So 4 equal groups, your number of arrangements is going to be the total number of arrangements, okay, over not the size of the groups, but the number of equal groups that you have. So whether there are 20 people in a group, or 4 people in a group, okay, in the equal groups, or 7 in the equal groups, doesn't matter. It's how many equal groups that you have. So if we took this combination and we didn't want to go through this whole spiel, we'd say we've got a group of 2 and another group of 2. Okay, what is the number of arrangements that we can choose these groups from 4 people? Okay, well, we'll start off and say we don't worry about overcounting in the beginning. Okay, so we're going to say we're going to choose 2 people from the 4, and so it's times. Then we've got to choose 2 people from the remaining 2. All right, 2 from 2. Yeah. So, okay, 2 from 4 and then 2 from 2. That's right. Okay, all over. Now, how many equal groups do you have? Well, you've got 2 groups of 2 people. So it's not because there are 2 people in the groups, it's because there are 2 equal groups. So it's divided by 2 factorial. And if you go shove that into your calculator, you're going to get an answer of 4. Right.
Then why does it say 3 there?
You're going to get an answer of 3. 3. Well spotted, Brogan. You spotted my deliberate error.
I'm a math
This
genius.
is why you've earned your salary.
Thank you.
Pause.
Good.
So we are going to start off with what we learned last lesson.
No, it's a different class. They've never seen this.
Shame. I will teach you how to draw a pig. So you're going to go, here's the song. 1 circle, 1 circle, 1 big circle, 1 circle, 1 circle, 1 big circle. 1 circle, 1 circle, 1 big circle. W, 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 E.
Bravo.
But this is a pig from the front.
Here's another colour.
No.
Oh.
Here is a pig from the side. Same method, just a little different.
And same song.
Yes. 1 circle, 1 circle, 1 big circle, 1 circle, 1 circle, 1 big circle, 1 circle, 1 circle, 1 big circle. W, W, E. We just miss out those 2 W's and all of those.
Right. Thank you, Ambrin. Okay, well done. It's very informative, and the sad thing is, okay, they'll probably remember this long after they remember anything about combinations, blah, blah, blah. Right. Just one little aside. You should really be able to do these type of 3 things without a calculator. Remember, your fundamental definition using factorials for n, c, r, in other words, from n choose r, is, well, it's like the permutation, which is n factorial over n minus r factorial, and then get rid of the order within the group, so it's over r factorial. So, nc naught, okay, you'll see the answer is going to be equal to 1. Up and right. Okay, if I use the rule, it's going to be n factorial over n minus naught factorial, okay, divided by naught factorial, which is simply the n factorials will cancel out, and you'll be left with 1 over naught factorial, which is 1. So anything.
But Raj.
How many ways are there of choosing nothing from n? There's only one way of choosing nothing. Okay, right. NC1. Okay. Well, the answer for that you'll see is going to be n. Okay. You should just kind of know that as well. Anything C0 is 1. How many ways you have of choosing one thing from n? Well, you've got n ways intuitively, but if you want to use a formula, okay, you're going to have n factorial over n minus 1 factorial over 1 factorial. Now the neat bit, you should know this as well. N factorial is the same thing as n times n minus 1 factorial all over n minus 1 factorial. They cancel and you're left with an answer of n. What did I say?
You said it.
Did I say? Okay. Right. So the n ways choosing one thing. Then NCN, the answer is going to be 1. Okay. And it will be n factorial over n minus n factorial over n factorial. And once again, those will cancel. You'll be left with 1 over 0 factorial, which is equal to 1. So it's worth knowing these things. It can save you a bit of time on your calculator. Number of ways of choosing 0 things from n is 1. 1 thing from n is n. And n things from n is only one way you can do it. Okay, so that's worth remembering. Right, back to your notes. Example 3. Now remember, with equal groups, that when you're choosing equal groups at the same time, that's when you've got a bit of a problem, and you've got it then, and you'll overcount. So what do we have to divide by to compensate for the overcounting? Okay, the number of equal groups factorial. So in this case, we've got 20 people, and we're going to allocate them into groups of 4, 6, and 10. Well, there's not a problem with equal groups here. Okay, so we're going to say, right, I'm choosing, and it doesn't matter which order you go in, I'll show you now. You're choosing 4 people from 20, right? Now you've chosen 4. So how many have you got left to choose? Okay, you've got to choose another group of 6. You've used up 4 of those people, so we're choosing 6 from 16. Okay, now I've used up 6 of the 16. Okay, so now I've got to go choose 10 from the 10. Okay, and if you shove that into your calculator, Rogan, you will tell us, no you won't. Okay, the answer you should get is 387. I'm going to give Rogan a little test now and see if he manages. 98760. Brogan, how would I read that number out loud?
Whoa.
Here's a hint. Do that.
Calm down. 38,798,000